The GFL-1500 array mode has two options, high and low, and that's the amount of current that's being sent through the signal. In most cases, especially when you have a low resistance solid ground fault, high mode is going to be the optimal option. In some cases, when you have a high resistance ground fault, that's too much current to pass through the ground fault. So using the low option will still allow it to be able to source the signal from the array, and it might be easier for you to trace in those situations where you have a high resistance ground fault. So you can see that I'm currently in array mode high. That's the default mode. If I want to switch to low, I go to mode and I long press, and then it will switch to low. Now it's sending that lower current signal through. It might be more effective for those high resistance faults. So the difference between high and low mode is really related to whether you're seeing signal or not. So if you're in high mode and when you were in analyze, you measured a high resistance fault, if you're not getting the signal in high mode, it can be, well, first thing you want to do is check and make sure that the unit is set up properly. Check at the test leads and make sure that you have signal there. And then switch to low mode. You can see the signal change and then go out and do your testing throughout the array. It might be easier to pick up that low signal than it was with high signal in a high resistance fault. Another issue we run into is with arrays with high capacitance, that's high parasitic capacitance, where we get some current leaking to ground naturally in the array. In those types of systems, the signal can be seen, it seems like the signal is seen everywhere, and that's because the signal is leaking through that parasitic capacitance to ground. In that case, the clamp meter has a feature called band pass. That's the BP button. And what that does is the signal has two components, a high frequency and a low frequency component. When you turn the band pass on, it's only looking for the low frequency component of the signal, and that is less likely to go to ground through that parasitic capacitance paths. So if you're having a problem where you know you have high capacitance in the system or suspect there's high capacitance in the system and you're seeing signal everywhere, use the clamp and switch that to the bandpass mode. Now, this only works if you're sending the signal from the transmitter in array mode. It will not work if you're sending in unit mode. So make sure that you have it set to array mode. It could be in either high or low, and then use the clamp, and that may allow you to locate the ground fault easier in systems with high capacitance. So let's take a look at the difference in current measurement between array high, array low, and with the bandpass filter on. And I'm injecting onto the negative side because I've got the positive fuses isolated, removed. So I'm going to start by hitting trace so I can put the signal in. If I take my current clamp here and put it on my negative lead, I can see in array high, I'm getting about 28.8 milliamps there. Now, if I hold the mode button for 2 seconds, it'll switch to low mode, and that current level is going to drop down, running right about 5.6 milliamps, 5.5 milliamps. So it's a lower signal, but it might be easier to see that signal with high resistance faults. Now, if I switch the bandpass filter on, it's dropped down even more to 3.6 milliamps. Again, if I've got an array with high capacitance, it might be easier to see that signal there. Now, if I switch back to high mode, that current level is going to go up. Now I'm at about 18.5 milliamps. So quite a bit lower than what it is in both high and low mode with the bandpass on. But again, in certain situations, especially high capacitance arrays for bandpass, that might be a more effective way to trace the signal.